All right, now that we know something about units, let's talk about conversion of units. So we use what are called conversion factors, conversion factors. And those are ratios of units. And they're always going to have the form of x with its unit divided by y with its unit, right? So whenever we convert, we're converting from the same property. So we're converting from length to length. So it's something like 1 mile is 5,280 feet. So this is length to length as a conversion. So conversion factors always need to have one unit on the top, one unit on the bottom. Okay? So when you convert one unit to the other using one or more conversion factors, you're multiplying. So for example, if we have 36 milligrams as a mass, and we want to know what that is in terms of grams, if we have 1 gram per every 1,000 milligrams, you multiply everything through, divide if you need to, and you get 0.036 grams. Okay? Important, carry your units along with your calculations to avoid making mistakes. If you drop your units in your equations, you're more likely to make some kind of a common error, right? This is really important in the real world. It's also going to help you gain an understanding of some general mathematical expressions. If you're watching what variables you're multiplying and you're keeping the units there, you're going to really start to understand what's going on in the system, right? So this is going to save you from common errors, gain an understanding of mathematical expressions. Really good habit to get into. It's just going to help you out. When we have multiple of these conversion factors, this x over y up here, and we have multiple of these in a row to try and convert multiple different units, sometimes that's referred to as what we call a dimensional equation. And it's just a series of those conversion factors, one after the other. So these can get really complicated really fast. So up here we go from length to length, but you can also go from length to mass and then mass to volume, and you can do all sorts of conversions one after the other. So that's really, really, really important as we're going through. And so if you flip your notes over or grab your next page, because that's where it is, a dimensional equation is going to have the quantity with the units that you're starting with it. It's going to have your first conversion factor, your second conversion factor, dot, 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 all the way out to the number that you need. So as a quick example, let's take a look at converting an acceleration in centimeters per second squared to 1 kilometer per year squared. And so you'll notice here, right, we're converting from a length over a time squared to a length over a time squared, right? We're not changing the number, we're not applying equations, we're just changing the units so that the number makes sense to us. So if we were going to do this, we would have 1 centimeter squared, 1 centimeter per second squared to start with. That's the quantity up here in this conversion factor. And then the first thing we want to do is probably change the time or change the length. Start with one or the other so you don't confuse yourself. So let's say that we want to go from seconds to hours, right? But this is a second squared, so just keep that in mind. There are 3,600 seconds per 1 hour, but because that second is squared, we need to make sure we square those numbers as we're going through. So don't forget that. There are 24 hours in one day, but if we want the hours to cancel to give us days, we have to make sure that this is squared as well. If we want to go to years, we have 365 days per year, but again, days are squared here, so we need to square that quantity. And that's going to take care of the time component. Now we next need to take care of that length component. You'll notice this is quite a long dimensional equation. We'll have 1 meter per 100 centimeters. We don't need to square this one because our centimeters are not squared over here. And then we have 1 kilometer is the same as 1,000 meters. This is a 100 here. I apologize. I'm right on the line, so it's a little hard to see. But this is what we call a dimensional equation. So we go through and we do all the multiplication, we do all the division, and just to round us out so you have the number, 9.95 times 10 to the 9th kilometers per year squared. So this number right here doesn't necessarily mean a whole lot to us in terms of those units don't really make a lot of sense. Centimeters per second squared is normally something that helps us a little bit more, but if we needed to, we could get here. So key things here to wrap up this video. When you're doing these dimensional equations, you're canceling out units. You're making sure that if something is squared or something is cubed, you're including that in your transition as well. And you're making sure that you multiply all of your numbers and divide all your numbers through to get the proper equation. And that's where we'll pause on this video.